In last class, we looked at a case of particle in a box, which can also be treated as infinite potential well with infinite potential outside that box. Today, we will look at three numerical problems based on that. For the first part, the probability of finding a particle in the interval delta x is given by this equation. Here delta x is 0.01a, therefore we can find out now the probability. Here notice that the wave function, you will substitute the value of x. X is here the initial value of the interval, the initial value of x in the interval. Notice here, here is the square of the wave function. An important point is for the ground state n will be equal to 1 because that is the lowest energy state for this. Notice here, here I have substituted the square of the wave function for particle in a box in its ground state. So for ground state n will be equal to 1, which is the lowest value of n. This comes out to be 0.02, which is 2%. So probability of finding the particle between 0.5a and 0.51a here is 2%. Now let's look at the second part. Here the formula for average value of x is given by this integral. Here you have multiplied square of the wave function with this value of x. Whatever the average value you want to find, here average value of x, so I will multiply it with x, and then the wave function, square of the wave function, and then dx. Here also notice that the limits are 0 to a, where a is the width of the box. It's not extending from minus infinity to plus infinity in this case because the wave function does not really exist beyond these two limits. That is why it has been reduced to 0 to a in this particular example. Now in this part also, here n is equal to 1 for the ground state, so I've just written the wave function. I think for part A also I forgot to mention it's for the ground states, so n equals to 1 in the wave function in part A as well. So if I ask you a problem in exam or homework, it will be specified whether it's for the ground state or for nth excited state, and you can choose the wave function accordingly. So here average value comes out to be a by 2. Now let's look at second question, where we have to calculate the probability of finding the particle somewhere in the region between 0 and a by 4 in its ground state. Again, for ground state, n is equal to 1, and this is how the wave function looks like. We know again the probability of finding a particle is given by this formula. Just don't confuse between the average value and the probability. Here there is no x multiplied here, so this is the equation for probability. Just one correction here, x was missing from the wave function equation. So now if I substitute, equation will look like this. In order to solve the previous integral, let's assume y is equal to pi x by a, so that dx is equal to a dy by pi. And because of this substitutions, limit will also change. If x equals to x limit goes from 0 to a by 4, now for y the limit will go from 0 to pi by 4. After solving the integral, we get this value, but here I have this symbol that shows that I have not yet applied the limits. So once I apply the limit, I get this value which comes out to be 0.091 or equivalent to 9.1%. So hence the probability of finding the particle somewhere in the region 0 between 0 and a by 4 is around 9.1% in ground state. Let's look at the third question. What would be the probability of finding the particle in very narrow region delta x equals to 0.01 a wide centered at x equals to 5a by 8? This small region delta x of 0.01 a is much smaller than, actually not L. Here we are taking A as the dimension of the box. So let's say, so this small region delta X is much smaller than the width of the box A. So we can take approximate probability as P equals to Px delta x. Again, this probability of finding x is a square of the wave function. So here I have the square of the wave function for n equals to 1 and then multiplied by the small interval. When I substitute the value of delta x and x, we get the probability value of 0.017, which is equal to around 1.7%. If I plot the probability density as a function of x, and here a is the width of the box which extends from 0 to a, we get something like that for a particle in a box in its ground state, that is n equals to 1. So what we just calculated was the probability of finding a particle in this very small region of the box, which is 1.7% now. So in this video, I gave you 3 examples of calculating the probability or average value in a given question, and so far we have only looked at particle in a box. So that's why in all 3 problems I have only considered particle in a box and in its ground state. If a particle is in first excited stage, then you will substitute n equals to 2 in its wave function and solve accordingly.